Hey folks, thanks for coming to this talk. My name's Jack. I'm a solution architect for Epic. Is that fading back? Is that okay? I just sound very loud. Good. I'm a solution architect for Epic. I don't want to talk too much about myself because I honestly have so much to cover when it comes to the topic of collaboration. So this talk is a little bit of an extension of a talk I did last year for NZGDC. I don't know if anybody caught that, but the whole concept was around collaboration. And this one goes a little bit further and a little bit more specific than that one, where we're going to be specifically kind of going into tools and processes to help you when you're in the thick of production. But we're going to be focusing on project setup specifically. So essentially building infrastructure, okay? Who is this talk for? Well, firstly, I'd say producers. I'd like to make an argument that to ensure that there's enough time in your initial project milestones to really give these processes a chance. We're going to be looking at a bunch of tools that should make your projects have better visibility. Probably best of all, reduce onboarding, okay? Tech artists, I'm going to be showing you a bunch of new tools and toys, which is always pretty exciting. I'll be trying to focus on how these tools interact rather than going too deep into the tools themselves. And finally, artists. I'm really glad if you're an artist in the room, you've come to see this. Even if you've never necessarily made a pipeline for a team, I think it's really important that we all understand the limitations of any workspace that we're actually working in, right? The other thing is, I would say that your voice is the most important voice in any process, because this whole thing should be framed around you. Or you're this thing that I drew. I don't necessarily think that this talk requires to talk about roles. I am pulling them out because it's convenient, but in a lot of cases, this might be a bit of a combination person, looking at Keegan over there. But basically, we're going to be focusing at the moment between these two titans, pre-production and production. And to be more specific, the area we're talking about today is the technical vertical slice and the infrastructure you might build before a project actually begins, before you bring on giant teams to get the work done, when you're still able to be agile. So that's going to be the focus of today's content. Let's dive into the first area, which we're going to be talking about. So I want to start sort of conceptually before we do a very sort of technical talk, just to frame the conversation. And the first thing, we'll start with the technical vertical slice. Of course, this is a small but complete section of your project. It should act as both an aesthetic proof and a technical proof in your project. So our main goal in a technical vertical slice, at least in my opinion, is to fail. We want to fail well before we scale up our project, find the issues, correct them, and proceed. This is done, once this is done and you're done with failing and everything works as best you can, I'd like to suggest something else a technical slice should be able to do. It should inform how a level is made. It should inform how we're separating our content. It should inform how we're using naming conventions. It should be a key piece of documentation that we can use for onboarding. It's a document that should define what good looks like from every single aspect, whether that be aesthetic, organization, production, all of them. So let's just go through what this typically looks like. Of course, the most fun phase is actually taking the concept art of your game and seeing if you can build it in the engine, which involves, maybe making a new type of cell shader or whatever technical sort of thing that you end up building. It might even involve iteration on a style as well. Defining cameras, setting up post-processing, etc. Obviously, it's really important to understand the gameplay and the design, what effect that's going to have on things like scale, pivot, very kind of boring things, but we need to be able to define these and document them. How modular versus not modular? Are we using procedural systems? How does that affect things? Level blockouts, what are our level blockout tool sets as well? The next thing we need to make sure we do, if we're going to take this process where a technical vertical slice is going to be documentation, is we need to be clean, right? And that means defining things as small as how we're going to be using RVTs to more complex decisions, how we're going to use materials and material instances, and even content organization. Are we planning DLC down the track? What is our update plan? Are we going to be using chunks, packs? How is our content going to be broken out into sections? Of course, once we do all this, we grab our very sexy technical vertical slice. We throw it on the platform. We see it's running at 4 FPS, and we go, okay, bit of work to do there. And we get all that working nicely on device. But at the end of this process, we've got this great looking, perfectly organized, neat workspace that is a gold standard. Okay? Let's talk about project setup. The technical vertical slice has provided us with the answers, but if we can't implement those answers at scale, ultimately it's only going to be useful for potentially showing to publishers and showing off on Twitter. Both of these are noble pursuits. I am just saying in the context of this talk, we want to go a bit further. So project setup should essentially be able to turn these learnings from the technical vertical slice into meaning that can scale into new biomes, characters, and ideas. Basically, the goal is to set up a simple, the goal of this step is really simple. We just want to ensure that we can distribute our project and onboard our team in the most effective way. All the problems that were solved in the technical vertical slice, once again, are useless if people can't understand them and execute the same pipeline. So there's a lot of things that you would do in this phase. They're all boring, but I would say very important. The one we're going to be focusing on this talk is pipeline. So to make this relatable, what I like to think of is when you make that amazing material that you're really proud of, and it's got this amazing visual effect, someone else opens your material instance and they go, what have you done? They're looking like 1,000 knobs and dials and floats with strange names, and they have no idea how you actually achieved this amazing outcome with magic numbers. I don't know if this is relatable to anyone, but I've certainly been on both sides. They're frightened, they're deeply frightened, and you've done that. Pipeline can be looked at as how are we actually interfacing with the project? Is it efficient? Does it cut down on onboarding and labor? What is the user experience of making this game? Or project, I should say. So I guess the point I'm trying to make about all this is it's a lot of work, typically done with a smaller, tighter team before we scale development. But having a workspace example of what perfect, or at least good, looks like will really help when you get to hellfire and chaos of production, because at least you can point at your golden target. And remember that Epic has the same problems that you do, and we have a host of tools and processes that can help. So with that being said, I'm going to go through all of these tools, and I want you to keep this kind of more conceptual phase of the talk in the back of your mind as we go through them. Let's start with materials. Every project is going to have this problem. The general problem with materials, or rather the situation that we find ourselves in, I relate to a kitchen. If a kitchen is dirty when you start a meal, it's going to get dirtier. If a kitchen is clean, typically it's much easier to keep that kitchen clean unless you're me. But however, unlike a kitchen, we also need to serve content in a way that makes sense to Unreal, which is something my blenders never asked of me. At the end of the day, this ends up being quite a tricky and impactful decision. So let's just start about why we would limit master materials, which is a concept that I was introducing in a talk that I did yesterday. And I can't show this slide because it's still compiling. That's a terrible joke about Unreal. There you go. And I guess, of course, that is my first point, is that we need to watch out for shader permutations. We need to limit the amount of materials we have to reduce shader compiling times, but also the size of our cook, okay? Asterisks point there, it's not necessarily true that limiting master materials is actually going to be limiting shader permutations. A big reason why we want to reduce master materials, however, is that if your material situation gets out of control, it's very hard to maintain constant functionality across your project. Additionally, it'll be much harder to onboard folks because they've just entered a kitchen of chaos, right? There's no point where you can start and understand where you're going to go. So is the answer monolithic master materials that do every single thing? Well, if it is the answer, then switches are the solution. Switches allow you to keep expensive material functionality disabled when it's not needed. And this is great because at runtime, you won't be running that shader code. Switches allow you to turn off and on functionality as simple as like RVT blending or other features like that. There's many flavors. They also come with material quality expressions, and these are awesome if you're working across cross-platform, right? Because it means that you're not using different master materials at a per platform level, which is nice because the alternative is a nightmare. But what we need to be aware of is that each switch will stop runtime code. It still needs to be compiled as a separate shader permutation. And what I mean by that, let's look at the worst case scenario. This is misleading, and I'll talk about why in a minute. But we've got a material, then we use a switch. We have two permutations. We have a switch, so on and so forth. Right? But what I would say here is that this is misleading because we're only creating a permutation for each used set of switches, right? Which kind of means that you could mitigate bloat by carefully constructing your material hierarchy. The point I'm trying to make, however, is that this exists and still you need to keep one eye on it in large projects, okay? The next big thing to watch out for in terms of this is in the material editor, and that's usage flags. So usage flags add a new set of permutations for each type of thing they support. And this will be multiplied with all your switches that you're currently using. In fact, there are several places where we need to watch out for permutations, each one multiplying into the next. But this does not mean we avoid using super useful switches. Remember, the advantage of these permutations are ensuring that we don't execute instructions at runtime. It's not suggested that you would say switch out to using if statements or lerps or something like that instead of using switches, right? That's not what I'm here to tell you. Don't do that. Permutations ultimately are your friend. Let's just keep one eye on them. So when is too much? Well, now permutation's been explained. What are the main cons for a monolithic master material? As established, if you have too many permutations, that's going to add time to your cook and also your cook size, right? But did you also know that unstreamed textures, references in unused switches, or nodes just sitting there not connected to your material, are still going to be cooked and loaded at runtime? Which means that if you just have a reference to a texture floating in space in your material, it will still be cooked and loaded at runtime. So unlike permutations, this can have an effect at runtime, okay? Let's have a look at how Quixel handles this problem. This is a reference graph. Here you can see the master materials that they're using are very broken down in terms of exactly what they need to do, right? But they're all using this function, mf map adjustments, meaning that if they want to make a change, they could add that into the material function. Basically, we can use material functions to share this common logic, and that gives us the organizational advantages of a monolithic master material. This is kind of the solution to the problem, right? Another answer that we could go down is custom primitive data, where essentially we're reducing material instances, but basically we're doing this by holding float values on a mesh rather than holding float values on a material instance. So let's just have a look at what I call the three saddle scenario. If we had lots of saddles and we wanted different colors, sure, we could make different color parameters and make material instances of each one. But if we use custom prim data, what we're able to do is actually put that value into the mesh itself. So without any value in the mesh, obviously they're all going to be black. But if we head over to rendering and then we go to color, we're able to color these all the pretty colors that you'd want in a saddle. Obviously, vomit green is my preference. Takeaways. Well, the first takeaway is to ensure that your master materials are specific to their use case. As people responsible for laying out these master materials, we need to find a balance between performance and usability. Rules are only good if they can be followed at scale. Ultimately, there's a lot to digest, and we can see it's no simple task to lay out materials for our project. That's why these decisions should be made early on in the clear project setup phase. Not to mention that pipelines should be used to make it easy for teams to follow. Speaking of pipeline, let's talk about import pipelines. Obviously, with any Unreal project, you're going to be making a lot of content outside the engine, right? Which is why it's so important to think about ingestion as one of the core things that you're going to be doing. Ideally, a strong pipeline should enforce standards, minimize repetitive tasks because they suck, make onboarding easier, and allow you to re-import mass data if your processes change, i.e. you've got non-destructive workflows where you can. Let me start with something very cute, relative import paths. So this is just something you can do that a lot of people don't know about, so I'm bringing it up, where you can actually, in your editor preferences, change your import path to be a relative path. So if you're sharing a network drive or on Perforce, you've got access to your source assets, you can keep your source assets in a relative path away from your project, and then everyone on the team can re-import an asset rather than being like users/jackc/project, you know? And so this makes re-importing really easy for everyone on the team. Very simple to set up. The next thing I wanted to talk about was interchange. So interchange is Epic's new import system. What makes interchange different? Well, it aims to be file format agnostic, meaning that systems can scale to work with any file format, right? This doesn't mean it's going to support every file format out of the box. It means that its architecture is designed to reuse huge chunks of code. Now that helps us because it makes things easier to maintain, but it also helps you. It is asynchronous. And what this means for you is if you are importing large scenes with lots of assets, you can make full use of your hardware, right? Which is always nice. It's customizable. This is what I'm excited about. Interchange aims to be extremely flexible, and it's the perfect base to start building your pipelines on top of, right? And what's obviously not covered, because we're talking about setup, is that it works at runtime, which means that you can make it import assets in a predictable way in your package projects. Not covering that. Very easy though. Today we're going to be working with GLTF files. I've stolen them from the Kronos group. Great place to get sample models. Why am I showing you this JSON file? Well, the point I'm trying to make is that every file format is obviously just data, right? In this case, human readable, so we really understand that. Here you've got a file that describes meshes, offsets, materials, material attributes, all structured in the way defined by GLTF. And this makes sense that all formats of data, so the first thing Interchange has got to do is translate this data into a unified way. Okay? So GLTF can also describe the scene, so if I import this into a level, it will retain its hierarchy and position in the world outliner. I just wanted to give you a sense of what interchange looks like before we get really technical. I just want you to smell it, see it, kind of, you know, just see what it looks like. And then we'll kind of go into the more technical. But lo and behold, I have a camera in the world. So, you know, that's important for an importer that it imports. There you go. Another cool thing that I wanted to point out is it creates this little file here. And this is that non-destructive area of it. If our GLTF file was to change, we could do a re-import, and it contextually can map back to our level import and update that, right? So you've got that forwards capabilities there that are really important. So let's go through Interchange's key terms before we dive into how we can use it. The pipeline always begins with a translator. This is responsible for turning whatever file format we're using, in this case GLTF, into a generic interchange format. The format is held in nodes. A node could be anything. It could be a texture, a material attribute. It could be a mesh. It's all the information that makes up the file or the asset we're looking at, right? That's just generic nodes. These nodes get fed to an appropriate pipeline stack. These are customizable to set up, but set up, they're originally set up like basically as everything you could need, I suppose. And this should make up any bulk action that you're doing, right? Each pipeline stack, I'm going to say the word pipeline so much, just brace. Each pipeline stack is an ordered array of pipelines, plural. Each pipeline is responsible for doing something to our nodes. Pipelines can also contain pipelines in them. And this makes sense in the context of, say, our asset pipe, which is dealing with, say, like an FBX, where it would also host a texture pipeline and a material pipeline, as well as like a static mesh pipeline, because they're the things that make up that. There's multiple things that need to be made, right? Ultimately, the main thing these nodes are probably going to do, because they can do a lot of things, is create factories. Now, factories are ultimately responsible for creating new assets. That's how we get there in the end. It's worth noting, however, that factories are also nodes. Now, it's okay if you lose me here, but the important thing to note here is that factories don't execute right away, which means that other pipelines are able to manipulate factories before they fire. This is very useful to modify existing pipelines, right? All right, let's look at this in context to our import menu. I'm going to flip through this pretty quick. Here you've got your pipeline stack. This is sort of defining, it's context sensitive depending on what you're doing, and it's defining what pipeline stack you can be using. Here you've got your individual pipelines, so there's steps you're going to go through. And here you've got a customized display unique to each pipeline that is indicative of what that pipeline is doing. So we can ask questions about how you want that pipeline to work. And if we look at that live, let's step through this import and explain what it's doing. This first one is the generic asset import. It's reading the GLTF file and grabbing everything it needs to make the factories. It is in fact creating the factories, okay? The next step is our generic level pipeline. It's grabbing these made U assets and sticking them in the level where the GLTF node says they go, right? It's just placing them in the world. And finally, this is unique to GLTF, you've got the GLTF pipeline. And basically this manipulates the factories that have been created to all the material factories to instead use GLTF materials, right? And that's just to achieve a look, a closer look for the import, right? So it's unique to this import type, which of course is customizable. And so the reason I'm using GLTF today was because I thought this architecture was cool. If GLTF is important in your project, great. But what I thought was cool was, as a code example, it actually shows us how we can modify the existing pipelines and implement our own material instances in a way that could scale to your own pipelines, right? So everything I'm showing you here, okay, who cares? What can you do, right? That's the bigger question as well. So if we look at our interchange project settings, this is really, really customizable. We can see that we've got different pipeline stacks here. You can make your own new ones, or you can build on top of what we got. If we dive into one, we can see that in case of an asset, we're going to run one pipeline, and that's the default asset pipeline. As I said, it builds factories, whatever. But note, within a pipeline stack, we have these per translator pipelines, okay? And the idea behind that is that if we're using a different translator, like GLTF, right, then we can customize our pipeline stack to be specific to that use case, right? So we can be quite modal in how we use this stuff. Additionally, both default asset importers we saw with GLTF and standard asset import have slightly different UI. Now, this is actually achieved really easily by making your own pipeline in the editor. And then you can set default values and actually show or hide any UI. So without doing anything, this is already kind of powerful. Because if you're using the, say, the material instance override in your FBX importer for your team currently, you can set that up and ship that so everyone can use those default settings. That's like base level interchange. You're already getting benefits out of that. And finally, interchange also supports easy to use automation testing, which you can basically run and import through a pipeline and then just check their variables on the other side of that. If you want to add to the tests you've got, you can do that pretty easily with C++. Takeaways. We can make our own translators to handle bespoke data types if you have them, if you're using them, right? Pipelines can be reused to create modular chunks. It's very easy to configure what are to see during import, setting default properties and hiding options altogether, and you can write your own tests. Very, very cool. But what about hacking it to do things other than that, right? Because file formats or whatever. Well, we can make our own pipelines to add to pipeline stacks. And we can do this in Python, Blueprint, or C++. Let me bash out some code that's going to ensure that sRGB is ticked if we are importing a texture with base color in it. Just pretending that's our standard, right? And it's kind of as simple as that, right? So what I'm going to have to do is add my pipeline to all the pipeline stacks that deal with textures. That's pretty much all of them because it's texture. Interchange provides a ton of hooks to manipulate nodes within the assets import process, okay? In this instance, I want to edit UAssets that have been created after the factory nodes have done their job. I'll set up a bool for our users to tick, and we can see that it automatically propagates into the menu for that pipeline. From here, we can see it working. So basically, I've got this global, and we've got a little bool there, and we're making custom UIs for our import pipeline just like that. In this example, I've made an editor utility widget of a Kanban that is tracking assets in development. I've got some cute features like if you click it, it opens up the asset. I don't know, I probably spent a little bit too much time on this example. I felt like it was fun. But you can see that I've added the option to our Blueprint pipeline to automatically add new imports to the Kanban project, tracking it. And like it's only adding static meshes in this case, as I've got some nice parameters that I can add there very easily. So naturally, these two examples are kind of like quite novel. Unreal does a great job of identifying if it should tick sRGB. And a Kanban in the editor would need a lot more work. Interesting idea. But once again, I'm just trying to inspire different use cases that you could use with your pipelines. So the takeaway is that pipelines can go far beyond just creating and manipulating factories, even though that's kind of what the system was built for. We can expose these features to Blueprint and Python, meaning that give it to artists, see what they do, see what's going to make their lives easier. It's not always up to lead programmers to implement this stuff. And it's really modular, so it's actually quite fun to iterate on and just hack. You can do a lot of interesting stuff. The Kanban example, I want to talk about metadata now because that's really, really useful in production. So the Kanban example was made using both asset metadata and the asset registry. Now, the first thing I want to make clear is that asset metadata and the asset registry data are not the same thing, okay? This is a common misconception. And it's confusing because the asset registry is metadata about assets. So don't get that confused with asset metadata. You can kind of see how this problem can happen, right? But you should think about them as two different data sources. Asset metadata is saved to a UAsset itself, just like every other property or variable as part of that asset, right? And it can be seen, and it can be set in the editor or imported from DCC tools like Maya and Max and Blender, okay? Because asset metadata is saved to the UAsset, it means that assets must be fully loaded to read this data. Likewise, to write to it, we're going to have to dirty that asset. Here's an example of getting the metadata, very simple, just uses fname, and then a string, setting, same thing in reverse, what we'd expect. Here's what you'd see in, say, Maya or Max, setting metadata. That'll bake into the FBX and lo and behold, make its way into Unreal Engine. Now, why am I pulling this out? Because metadata can be read by interchange. Metadata can be read by visual data prep. What does this mean? It means that we can actually do bespoke ingestion branches or any kind of thing during ingestion with metadata because the engine supports that, right? Let's have a look at interchange being used for metadata on asset import in our Kanban example. Here we've just got a very simple script that I'm amending to our already existing pipeline. That's probably not a great idea. You probably want pipelines to do a thing, but in this example, I'm going to stack them all together. Once it's important that we can see it works just by right-clicking, and you can see any metadata that you've got in the editor, which is really quite useful for diagnosing. But you'll notice that it's not in the asset registry. The reason we can tell that is because we can't search for anything. So asset registry data will come up with queries but also when we mouse over an asset, there is an option for that to show up, like triangle count on a static mesh, right? It can show up there. So the asset registry data is different from asset metadata in that it builds a database side by side to our UAssets. This means we can access this metadata without loading the asset. It means we can iterate through this big list quickly. Rather than saving this data directly to the asset, it is formulated whenever an asset is saved or asynchronously when the editor opens up. It's generated based on rule sets provided by our asset. Not exclusively, the asset management tool can also do this, but it's more complicated. So how am I copying over the asset metadata to the asset registry in Unreal? This is something else that I don't think a lot of people know about, but this can be set up by going to Project Settings, Asset Manager, scrolling down to metadata tags for the asset registry. And by doing that, any fname that we're using for a metadata tag will automatically copy to the asset registry. So this is really useful because traditionally on things like static meshes, you'd have to modify the engine or make like a weird subclass of static mesh in order to give it metadata easily. There are other ways to do it, but like I'm just trying to keep things simple. This allows us to essentially give that option. What I would say is this is extremely powerful and dangerous. I think that it's very abusable. I think that with great power comes great responsibility, Spider-Man, whatever. But anyway, there it is, cool little tip. This data is being copied to the asset registry, so of course now we see it in our searches. So the takeaways here is that we can use asset metadata on assets to do bespoke actions on import. We can use metadata for our editor scripting. We can use metadata to be promoted to the asset registry if we ever need to query all our assets at once without loading them, okay? You can learn a lot more about using data in Unreal if that is something you're curious about by watching my talk. This is where I shamelessly plug stuff that I've done. I am biased, but I do think it's worth looking at, where I did a talk last year for Unreal Fest. This will make the graphics designers and art directors happy in the room. Unreal Engine allows you to save color values in the color picker and then share them with your team. So this is really important where you have very specific colors in your game, which is a very typical scenario, or project in general, right? We can just make new themes by dragging colors into this bar, and then we're able to name them, okay? And we can have multiple themes in there. Then we can actually create subnames. So I've got like foreground, background, and highlights, right? And I've got 3 themes there. Now, right now, this is only for you, which is kind of useless, okay? That's not very useful. But what you can do is go into your saved folder and configs and go to your editor per project user settings. Go ahead and copy that data, because that's where it saves. And you want to put that into a file that will be on source control for your team. So that's going to be in your project config, and you're going to save it to default engine per project user settings. This will now be shared, which means that during project setup, you can define all your important colors, and then you're never going to have people like slapping together UI and just being like, that's pink, because we've all done that. I will continue to do that unless you do this for me. That's my threat. Geometry toolsets are so important during this phase in terms of tooling. I don't have enough time to talk about how cool they are. I'm going to show you some things really quickly because they're great. The first I'm going to show you is just like where they are, okay? So we can go into our modeling toolsets, and here we can say we can do a bunch of things. Today I'm going to be using the baker, and I'm going to bake curvature data into this nanite mesh, all right? And yes, Unreal has a full texture baking system within it, which is kind of wild to me. In fact, it's wild that we have any of these geometry tools. Who would have thought they'd be so powerful? I suppose everyone. We can interact through a very manual DCC type way, or we can script all of this. We can also make tools with these. So we've got the new scriptable tool sets, and these tools came out a while ago. The 3 examples are going to show you Chris Murphy kind of put together when the tool came out, because we're trying to understand them. So the first one is the draggable tool. You can literally drag and it creates points. And then what he's done is added essentially a spline with generation on that to create like vines. There's clickable tools. So in this example, we're creating point light, and then we can change its rotation, trying to build better tools into your lighting pipeline, right? Very simple. Or go full hog and make your own 3D gizmos, right? And this one is showing and hiding different objects, right? But the sky's the limit if you can create 3D gizmos. Of course, there's also editor scripting. So we're going to be talking about how to set up editor scripting. Basically, we want to automate as many workflows as possible in pipeline. This helps in two major ways. Firstly, no one likes doing stuff that they've already done once. Generally, people like to do things once, twice, nah, boring. But it also means onboarding is potentially easier if we're able to do away the processes that are otherwise horrific. I come back to the master material with 1,000 knobs. So here we have a rock that has no UVs. In this project, it doesn't need UVs, but this rock called me and said, I feel like I'm not complete, Jack. Can you do something about this? And I said, well, I can write you a script to solve that problem. So here I'm going to make a script, and what I'm going to do here is I can say what supported classes it's going to work. I can say static meshes. I could probably use primitive meshes as well, actually, for this example, but I didn't. If I make a function and just say call in editor, it will automatically expose in the context browser when I right click, okay? So there's some fast code, but essentially I was scripting to auto UV this thing. Look at that. This is a simple example, right? But you've got a full tool set there to build your own bizarre things. I want to see them. The other thing I wanted to highlight was editor task utilities. These are really great because they allow us to run asynchronous tasks that can be update progress in like toast pop-ups in the editor. Do people see that, or is my head in the way? My head gets in the way. Whatever, they're toast pop-ups. They feel really professional when you do them because you're like, I made a toast pop-up and I could write text on it. But they're very easy to set up. So what we want to do is we want to make a task, which is just a new utility that we're going to child from editor utility tasks. Once there, I'll just paste our UV generation function. I'm not going to do that again. But we want to override begin execution. And I'll make some parameters because we're actually going to spawn this task. We're going to construct it, which means if I set things as accessible on spawn, it means I can fill these variables very easily, right? So let's go ahead and do that. I'll show you how to actually fire them off. I just use a create. And then here's the trick, is that you need to use the editor utility subsystem, register and execute them. And then they'll just run asynchronously. This is working, but we can add some text to make it very professional and we can be very proud of it. In this example, I'll show you that you can also connect these geometry toolsets to interchange, right? Talking about ingestion. So basically I've added a Boolean that will go ahead and ruin all the UVs of this camera, which has been very specifically UV'd for the textures. But using the power of Unreal, I can ruin someone else's work. I get a lot of questions on content plugins, which is a weird thing, and I'm struggling to answer, but I wanted to talk about it in this talk. I think there's been a lot of confusion from Lyra, a lot of good things too. Content plugins are normally associated with the modular gameplay framework, but they have seen a lot of success with some studios in a purely art-based fashion, okay? Now, why would you want to do this? Well, potentially you've got a piece of IP that you're using in multiple projects. That could be one reason, right? That's versioned externally and then pushed to all those projects. I do get asked a lot. My answer is it's probably not right for your project, but I wanted to come up here and just talk about it anyway. So the main thing here is that if you want to do this, you want to make your content really mobile, you've got to subscribe to a bunch of rules to keep that content mobile. And that really comes down to dependency. So I'm going to run through a very quick example where we've got a plugin in the yellow and we've got two projects and we've got Peely. Now Peely wants to live in both projects. That shouldn't be a problem. He's got sound files, whatever. We just make him a plugin and share it, right? Cool. Where this can get tricky is we've also got Bush Ranger over here, and we want to use some noise texture of Bush Ranger's amazing beard, which I'm attached to. And we want to make Peely have the same action. So all of a sudden we end up with a reference. But of course, I mean, this is standard referencing stuff. From the perspective of project 2, we now are missing an asset, right? So let's look at that. Making content plugin is super easy. That video didn't play. Let me just refresh Unreal because, sorry, PowerPoint, my current tool of choice. You can do it in the plugin manager. When you click edit, you'll get this menu. The first thing I wanted to point out here is custom virtual paths, where we can actually, rather than having content plugins all in the content directory, we actually give them magical paths where we can start to group them conceptually, which is really quite powerful because we can organize content in a way that we normally do, like in a project, rather than just having a vomit of a folder, which no one likes. I also want to show off the plugin reference viewer, which is new in 5.2. And that will let us actually visualize our plugins. Okay. Now we're running out of time. I wanted to show you that you can add dependencies, and that will create graphs where people can see what the content is dependent on. However, it doesn't do anything. Are artists going to look at your graphs and then obey them? They're not. Why would they? You need an overlord. You need a validator. You need asset validation. Okay? So essentially, it's a really easy way to write tests in your project to maintain order where there is chaos. We can make them really easily by child classing editor validation base. I'm going to rip through this, but essentially they've got 3 override functions that we deal with. The first gives us an idea of every single place a validator can actually execute from. They're really cool because you can fire them before you're allowed to submit to source control. You can also do it whenever you save, which is really annoying, but quite useful. We'll just tick it to true. Then you've got can validate asset. This is just defining what type of assets. In this case, I'm going to use texture 2Ds. And if they're called base color. Finally, you've got your actual test. So this basically ends in 3 different outcomes. And it's up to you to write that logic. I'm probably just going to test for sRGB because that's what I've been doing. Something like that. Pretty simple stuff. Now you've got a way to write out to the log through notice asset warnings, asset pass, and asset fail as well. Pretty standard testing stuff that people should be familiar with. We can run it and see if it works. I assure you it does. So let's go ahead and make it wrong. Now we can test from different areas. Like this was a manual audit, which I can run at any time. But remember, I've got pre-save and all those kind of options. Here, I've got an asset that references another asset that references another asset. So 2 assets that reference each other, like a circular dependency, which is okay in Blueprint. And I've got 2 plugins. They're in different plugins. This is a no-no according to our rules. Now, the way I've got this set up is that one plugin can reference the other, but the other one can't reference it. So we should expect to see a problem. Now, if I enable this plugin called the Asset Reference Restriction plugin, it's an implementation of the asset validation, and it will stop artists from breaking rules if there is no dependency there. So now your graph is going to be used. That is a tick box to turn on the engine, and it will solve many referencing problems down the line. It can be customized to add a lot more functionality as well, but extremely, extremely powerful. If you want to check on save, you can just do that in editor preferences under advanced data validation as well. How am I going for time? I am going to speed things up a lot, and rather than going too deep on what a derived DDC is, I want you to relate on your experience compiling shaders. What's that all about? Well, essentially, Unreal Engine is generating a lot of derived data that we'll actually use for rendering. It's used for a lot of other things, but if you see a PNG, that PNG is not what you're going to see in your shader, right? It's going to be based on the derived data. And the point I want to make is that wherever I've worked, there's always someone who comes in earlier than me. They've already been to the gym. They've got a coffee. They're like really perky at 9:30. And the shared derived data cache ensures when I come in at 10, I can steal all their work compiling shaders and start work at the same time as them. Okay? What we're doing is essentially I'm accessing a shared spot in your network. So to get this to work, that's all you need to do. And I can pull that data. Now that only works if we're not using work from home, which we are now, right? That's the world we live in. But if we're in the same office, this is going to speed you up a lot. Just to give you an idea of how that works, if we've got that data on our local derived data cache, we'll finish immediately. But if we don't, we check the shared, we'll copy it to our local and move on with life. If we don't have it, only then do we actually do compute on our own machine. Unreal Cloud DDC, not very well documented, I will admit, right now, is marked as experimental, but not because it hasn't been used in production, because it's still quite hard to set up, okay? It is very much being tested in production. Basically, this allows you to host that derived data on a cloud server. So for work from home, you're able to pull all that data. It also comes with authentication, meaning that your data is safe. Virtual assets work really well with these systems, okay? With projects getting bigger and bigger and bigger, it's very expensive to keep up with Moore's Law, and I'm not even sure if that's the solution, right? Well, let me explain how this works now that we understand the DDC and we understand how U assets kind of work. Flower.png, we copy over, right? Becomes a U asset. The U asset becomes derived data, right? We're following? What actually is a U asset, right? And this is what user B is ultimately getting when they pull it, right? The shred derived data cache and the flower. Inside the U asset is bulk data, which is the original PNG, metadata, which is like, is sRGB ticked, right? And a thumbnail because they're cute. This is what we need in the engine, right? That's what we're pulling or generating at the start of the day. What if we got rid of the bulk data? We don't need it. After we created the DDC, it's just sitting in there taking up like half the space of the asset. So if we go ahead and rip that and put the bulk data on the network and then keep the thumbnail and metadata because thumbnails are cute, what we've got is a much lighter project that's going to sync much quicker and take up a less hard drive space. This is all Bush Ranger cares about. Bush Ranger's happy. There's a lot of documentation on virtual assets, but they help a lot. My final point before I close up is texture groups, okay? Now, texture groups essentially help us define the way that textures are going to respond. Now, my suggestion here is probably everyone's heard of texture groups. I forced myself to put them in the presentation because you need to think about them early, right? You need to come with a plan early and enforce your studios using them because it will help you in shipping. Basically, they define what MIP or LOD resolution a texture should be shown, what happens when a texture is like minified or magnified by the GPU, and how a GPU should blend to MIPs at grazing angles as well. But they also affect how we treat them in the device manager, okay? And what I mean by that is that if we open up the device manager, we can see every single platform we might ship to, and we can make sweeping changes. For example, we can say all the world assets are going to have only 512 normal maps, but our character is going to stay at 2K because that's what's important on iOS, right? This is very efficient, but if you have the task of doing this during shipping, it's not fun, right? You want to do this as you're working and try to enforce standards. You can also rename them by using an enum remap. But ultimately, I think I'm very much at time. I was very worried about that. This is what we covered today. Now, in truth, when I made this slideshow, I had so much to say here, my presentation went for 2 hours because there is so much that we can be doing. And the way I hope you responded to this content was either I've already done that, and I'm so glad Jack's talking about it because it should be shared with the world. Or, I haven't done that yet, thanks for harassing me, Jack. Yeah, I know about that, but I'll do it one day. Or, hey, that was too much information. At least I wrote down the name of that so I can research it, right? But thank you for being on this huge journey. What I would say is there's a lot to talk about here. I want to hear what you're doing, and I want to share the other things that I couldn't fit into this presentation. So ultimately, if you want to continue talking about this, use this QR code to reach out to me while I'm here, and we can chat about your process and all the tools in Unreal that might help you with your next project, or hey, even the one you're in. DevOps will always help scale teams and build more efficiency in your pipelines. Thank you very much.